Hello everyone, welcome to this third webinar of the Navigating the Cyberland series. And the titles of this webinar is going to be Privilege Escalation on Linux Systems, something we call even local exploitation. But before we start, just let me know that you can hear my voice, that you can see the screen just by typing on the chat a confirmation. Okay, thank you, Roy, Guys, Anthony, Joseph, Haitham. Thanks, everybody. Thank you for being here tonight, this evening. This is a monthly webinar. We do it on the second Thursday of every month. We started on September, and then October, and now in November. The first one, we talked about auditing TLS and SSL websites. On the second one, it was a demonstration of capture the flag on Moonraker machine. And today's webinar is going to be about the privilege escalation attacks. And I also would like to say that the webinar is recorded, and you can view the recorded version of each webinar on the homepage of Axon Technologies at livestorm.co. So you have access to previous webinars as well, in addition to this one. Without further ado, let me start this webinar. Let me start the session by talking about the agenda. I will start by explaining the types of exploitation. There are different types when we talk about exploiting a remote machine or a victim. How do we exploit machines? What are the different types of exploitation? And where does local privilege escalation fall in that category? Because local privilege escalation is a type of exploitation. So we need to understand the entire umbrella first before we dive into local privilege escalation. Then we will introduce the purpose of privilege escalation and why do we need it in exploitation. And then I will be discussing 6 methods to achieving privilege escalation. There are different ways you can do, and you can like different steps and tests that you can do to become a root on a machine. The first one is exploiting kernel vulnerabilities. Then we move to exploiting services running as root. And then we exploit pseudo rights. If we get any pseudo rights, there's a way to exploit pseudo rights. And exploiting set user ID, set UID programs. And then we talk about exploiting cron jobs that are badly configured or misconfigured. And then finally, we can extract sensitive information like passwords from bash history. And by extracting sensitive information, we can elevate our privileges. So, types of exploitation. Exploitation is the process of getting access to the system, whether this access is a normal access, like limited privileged access, or it is a root access, regardless. So exploitation is a way of getting access to the system in a non-legitimate way or a non-standard way. So without knowing the password, without having the credentials and so on, you manage to exploit. There are different types, classified generally under 2 categories: remote exploitation and local exploitation. Remote exploitation happens over the network connection. As you can see in this diagram, the attacker is on a different machine, and the exploited or the victim is on another machine, and there is a network connection, and the attacker manages to control or exploit the victim. This is the remote type. The remote type is further divided into two classes, two further subtypes. The first one is server-side exploitation. In a server-side exploitation, the victim, as you can see in this diagram, the victim has a network service that is listening on a certain port, okay? Something like Apache or the web server Apache or MySQL database that is listening on a remote port, or a DNS server. Um, it could be Postgres SQL database. It could be email server listening on port 25. Whatever the service is, it has to be listening on a port over the network. And then the attacker connects to that exposed server and then sends through his exploits, he would send the payload, and then he would get a shell access. And then he would have an established connection controlling the exploited machine. This is a server-side exploitation. There is nothing the attacker needs to do other than connect over the network. Like if you can send a TCP packet or a UDP packet to the victim and the victim is vulnerable, you get access and you manage to control the machine. The second subtype under remote exploitation is a client-side exploitation. Unlike the previous subcategory, where the vulnerable application is a server like Apache, Exchange server, Bind server, DNS server, or whatever, in this type, it is a client application that is vulnerable. Something like WinZip application, Rear Player application, Acrobat Reader application, Internet Explorer application. These are client applications. They do not listen on a port number. They don't have TCP port listening on. They simply run on the local machine. Now, the attacker is remote. The attacker does not have access to the victim machine. What he needs to do, he needs to send his exploit through social engineering tricks, like phishing emails, for example. So he would send the exploit as an attachment. The victim will open that exploit, will open that malicious file that is in the attachment. Malicious file can be malicious PDF, malicious zip file, malicious document, Word document, Excel files. And when the user or the victim opens that file, his machine gets exploited, and then the hacker or the attacker gets a remote shell, now a remote access to that machine. So we got server-side exploitation, client-side exploitation under the remote category. The second category is local exploitation. Local exploitation has another name. It is more known as privilege escalation. Privilege escalation. It is an exploitation where you already have a normal access. You already got access to the system, whether that access is legitimate or illegitimate. So whether you have done like a remote exploitation first, and then you got you got normal access, and now you would like to become a root or administrator, so you do privilege escalation, or you already have a legitimate normal access. Like let's say you are an employee, you have a user account that is a valid user account that is legitimate, and you are authorized to use that system as a normal user, but then you exploit a vulnerability on that machine to become a root or administrator. What I would like you to note here is local exploitation. You do not have to be locally and physically present on the machine. So I can access the victim. Let me go back here, for example. I can access the victim remotely using SSH, but the SSH would give me a limited access, like a normal access. And then I run a local exploitation to elevate that access to root. That is still called local exploitation, even though I'm running it over SSH remotely. So the initial access or the normal access that you could have it through legitimate account, you could have it through SSH, you could have it through remote exploitation you have done previously. The bottom line is you have to start with a normal access. So I established a normal access, and then my normal access is limited. I am a normal user. I would like to become root. Okay, I would like to become root. If I am working on a Linux system, I would like to become root. If I am working on Windows system, I would like to become administrator or even system account. So since this webinar covers only privilege escalation on Linux, so we will dive into the methods that are relevant to Linux. Maybe in a future webinar, we'll talk about privilege escalation on Windows system. But for today's webinar, it's going to be focused entirely on Linux. If you have any sort of access to a Linux machine, you will notice that there is a slight prompt that you can see. Okay, I'm going to open here my VMware just to show you live. By the way, this webinar contains a lot of live demonstration and attacks. Okay, so it's only in the beginning. We have few slides. Later on, we will be having a lot of demos. So if you can notice here, I have this prompt. Okay, this prompt goes like this. I have the username over here. Okay, and then the host name, and then I have the directory over here, which is the home folder, and then I have the $sign. A $sign in Linux always means you are a limited normal user. Okay, a limited normal user, non-root. Okay, a non-root. However, if I become root, okay, I will see that the prompt has changed to hashtag. A hashtag in Linux means you are running as root. Now you are root, okay? While a $sign, you are a normal user. So if you go back here, if your access, if the type of access is with a $sign, it means you are a normal user. You have limited control over the system. There are a lot of things you cannot control. At the network level, you are limited. Okay, you cannot forge fake packets. You cannot spoof your IP or spoof your MAC address. You cannot even sniff in promiscuous mode. Okay, you cannot control a lot of drivers. You cannot stop and start services, etc., etc. You cannot create user accounts. However, if you are root with a hashtag, you are the most powerful account or user on that system. Okay, you can control all services, you can control all drivers, you can destroy any account, create a new account, change the passwords. You have unlimited control of your network sockets. You can access any file. Okay, you can delete hidden files, etc., etc. So that's why when you are a normal user, we always would like to become a root. So let us start now with the methods. Okay, these are the 6 methods that we'll be discussing today. Okay, we will start talking and demonstrating one by one. Okay, each one of these. So let us start with the first one, which is exploiting kernel vulnerabilities. Just like a network server or a network service can be vulnerable and you can exploit it over the network, okay? the operating system can also be vulnerable locally, okay? And this vulnerability, if you manage to exploit it, you can become root, okay? We are talking about here the kernel, the core of the operating system. So anytime you have a limited access, you have a normal access, you need to check the version of the Linux kernel you are working on. And the command to do that is uname -r, okay, or uname -a to get everything. And once you get the version, okay, you can search for any vulnerability that is associated with that version. Welcome, Eli. Thank you for joining us today. So if I go back here to my Kali Linux, okay, and I exit this root, I am here. If I type uname -a, okay, I can see the version is 5.5.0. 5.5.0 is one of the most recent versions of kernel, okay. Maybe it's very unlikely to find the vulnerability because this is released in 2020, okay. But we will explain other vulnerabilities in different operating systems. And most of the demos and the labs I'm gonna do today are implemented on capture the flag machines from VulnHub. Just like last month, we explained the Moonraker machine. Okay, there are other machines similar to the Moonraker. Okay, and we will demonstrate vulnerabilities and privilege escalation on some of those machines. I'm gonna give you the names of those machines so you can download them and practice on your own. So let me go to the first one. But before that, let me tell you something. Once you know the version of the kernel, okay, you can do two things. You can go to the website cvedetails.com, and CVE Details is a database of all vulnerabilities. So you can search for vulnerabilities on a specific kernel and see if that kernel is vulnerable. And then you can go to exploit-db.com and see if there are public exploits for that vulnerability. So these two websites are very, very important. CVE Details and Exploit DB. Okay. So we'll do two labs here, okay, on two vulnerable machines. But before that, the first machine is Typhoon. So I'm gonna now power on Typhoon. Okay. Typhoon is a capture the flag machine that you can download yourself from VulnHub. Just search on VulnHub for the name Typhoon and you will find it. It has a lot of vulnerabilities, and you can practice your penetration testing skills on. Okay, but for today's demonstration, I'm not going to explain the full process of exploiting Typhoon. I'm just going to explain privilege escalation on it. Okay, so since I have it now, let me find its IP address and map -sn for the entire range that I'm working on. So most probably this is the IP because .1.2 associated with VMware, .254 also associated with VMware, 139 is my Kali. This is the only one that is left, and that is the Typhoon. Once I know the IP address, okay, I already have SSH account on Typhoon. Okay, so sudo SSH Typhoon, the username is Typhoon, and then 192.168.127.248, and the password is 789456123. Okay, so I established SSH session to Typhoon, okay, with a valid username and password. If I do who am I am Typhoon. I am of course not root, as you can see here the $sign. So I am not a root. I have a lot of limitations. Okay, I would like to elevate my privilege. So I said the best way is to check the kernel version, and here I have 3.13.0. Okay, 3.13.3.0, and as you can see this is old. The latest version is version 5.5. So all I need to do is now I copy this, and I can go to the two websites I talked about, the CVE details and the exploit DB. I'm gonna go directly to exploit DB and search for any exploit for this version. And yep, I managed to see two exploits. Okay, this is the one and this one. This looks very similar to the second one, except that it has the access etc shadow. So it does not give you full access. Gives you it only gives you access to the shadow file. Anyways, and if I click on the second one, the general one, it says Linux kernel between 3.13.0 to 3.19. All Linux versions between these two are affected, okay, with something we call overlay fs local privilege escalation, and this is a C code here. That is the exploit. So if you manage to run this, we probably can get shell, can get root. Let me explain what this vulnerability is and what is the background of this. What is overlay file system? So the overlay file system is a type of a virtual file system that is supported on many Linux machines, and it provides the following features. You can merge two directories, okay? The first we call lower directory with an upper directory. So two directories, one is called upper, the other is lower. And then by merging them, you get a temporary third directory, the overlay, in which you can see the files of both directories. Okay, the bottom, the lower and the upper. So the lower and the upper files appear on the overlay. Okay, and this file system has one advantage, which is if one of the lower or upper directories is read-only, the overlay file system allows you to modify those read-only files. Okay. It turns out there is a vulnerability. By the way, the image and the description is coming from this source. You can see the URL here where you can read more information about the overlay file system. It turns out that kernel version between 3.19 and 21.21, okay, have like a bad check for permissions. So if either the lower or the upper cannot be accessed except by root, with overlay file system, you are able to access a root only directory and modify its files. Okay, and modify its file. This is the whole trick here in that version. So if I manage to merge two directories and one of them I have no access to, I cannot read or modify or write to it, with overlay file system I am able to modify, and this is the whole trick. So if I'm able to modify a root directory, I can inject my own exploit as a root and then spawn a shell as a root, and then I become a root. This is the whole background of this vulnerability. So let me go back to my Kali Linux and my Typhoon. Now, once I know the exploit, as you can see it here, I go to the raw version of it, and I copy the URL. Copy. Now at Typhoon, I am here, okay, at the home folder of Typhoon. I can download the exploit using wget. So paste, download. I should have it over here. Now, since there is no extension and this is a C code, I already know it's a C code. I can simply move it to exploit.c. So now it's .c file. And because it's .c, I can easily compile it now with gcc exploit.c. Once I exploit it, I have my binary here. Okay, so ls minus al. I have my exploit, okay, which I can execute. And if I run the exploit, I got the hashtag. And if I want to be clearer, I can do this little trick, okay, which is a Python line of code to spawn a pty shell, a pty shell. And a pty shell, all it does is give you the entire prompt here: username, add computer name, home directory or current working directory, and then the hashtag. So who am I? I am root. Okay, so by downloading the exploit as a Typhoon user, compiling it with GCC, running the exploit, since this is an old version, I managed to get root access. Okay, I elevated my privileges. Any questions so far on this lab, on this demo? Okay, we will demonstrate now another kernel vulnerability associated with a different version. That was the one we have done so far was version 3.13. Now we're gonna do a lab on version 4. Okay, and for this one I have the lab recorded already, so we will watch it on as MP4 file. Okay, I am accessing a machine here. Okay, using SSH with a username Peter, and that machine, by the way, is stapler. Okay, that machine is a stapler. So if any of you would like to download this machine from VulnHub, okay, you can simply search for stapler and download it. So I established my SSH connection, and I would like to get a pty shell with Python -c, this command line that I always type. Okay, once I get the pty shell, you can see the username at host name, which is red, and then the home folder, which is the tilde sign, and then the $sign. The $sign means I am a normal user, as I said, a normal user. Of course, the next step now is to check the kernel version. So always make it a habit whenever you have limited access, check the kernel version. Okay, uname -r, and as you can see here, it's 4.4.0. Now this is more recent than the previous lab, which was 3.13. But as you can see, as you will see, it is vulnerable to something. It is vulnerable to a major flaw that can be exploited and allows you to get root. So I will type here on exploit DB, I'm gonna type Linux 4.4.0. Sometimes if you don't get a result with 4.4.0, you can simply like make it more general with 4.4.x. Okay, and it looks like we have an exploit. Okay, we have an exploit. Now just let me show you what I did exactly uh, on Firefox. So I'm gonna access exploit here, and then Linux 4.4.x. Okay. As I said, sometimes 4.4.0 may not give you the exact result you are searching for because it's more general, 4.4.x, so from 0 all the way to the 99. And as you can see here, I have the exploit. Now it turns out if I check this, there is here, this is not a C file. It's simply a text file with some description of what the vulnerability is. And then at the end of it, there is a link to the actual exploit. And this is the link. So a zip file with the exploit. Okay, a zip file. So all I need is to copy this and download the zip file. So I copy the link. Okay, and I go to my stapler machine, and I'm gonna attempt to download the exploit, the zip file that I have found on exploit.db. I'm unzipping now the file. I can see there are few directories. I enter the directory. I can see two tar files. One of them is exploit.tar. I will untar the file, okay, which means I am decompressing the file, okay, exploit.tar, and then I get few source codes, okay, in a directory. I access the directory, and then I will see a compile, a shell script to compile the rest of the files. So instead of me typing GCC, the compile.shell actually compiles them for me. And then I have double put, which is the actual exploit now, the binary. Okay, and once I run it, I'm gonna find that I have a root access. In a minute, I'm gonna explain what the vulnerability is, the background behind it, what is going on here, and how the exploit managed to uh, take advantage of that vulnerability. So it is working on the background. It's trying to do its dirty work, the exploitation. Haitham is asking question, can we also use LSB release -a? Yes, of course. LSB-release -a gives you the version, the kernel version. So in any ways, you can use uname -r, or you can use LSB release, whatever command you can do to get the kernel version. This is what we are chasing, the kernel version. So, and then finally I got a root, and now I am a root. Okay, so what was this exploit? What was the vulnerability behind it? This vulnerability exists in something we call Berkeley packet filter. Okay, Berkeley packet filter. A Berkeley packet filter is an engine that works on network interface card when it captures network traffic. Whenever you run something like Wireshark or TCP dump or any favorite sniffer or any favorite packet analyzer, okay, you have the option to filter traffic. Okay, you can specify which port or which IP you would like to sniff from, or which type of protocol. And capturing packet happens through a certain syntax, and that syntax is defined as packet Berkeley filter. Okay, now on a specific version of Linux kernel, okay, there is insufficient check of privileges. Okay, because when you are a normal user, you cannot write BPF filters the way an administrator would filter traffic. Okay, you have certain limitations. However, because this particular Linux version is vulnerable, there is improper way of checking the permissions or the privileges. So what the exploit now does, it will attempt to insert certain BPF filters, okay, that is malicious enough to actually cause the sniffer or cause the driver that sniffs packet to uh, execute shell as a root, and then you will get a root shell. This is the whole idea of this vulnerability. And if you go to the to its documentation over here, it will explain exactly what's going on. Okay, so you must understand C to understand this code and to see where the vulnerability exactly is. Okay, with the map, with the packet Berkeley packet filter memory map. Okay, so there is something that is that's improper handling of privileges when the map attempts to call certain file descriptors. Okay, so we have demonstrated now two examples of getting a root through kernel vulnerabilities. And don't think that kernel version 5.5 is going to be secure forever. Maybe this year or next year, a vulnerability will be discovered, just like we had vulnerabilities in version 4 and version 3. We might get also vulnerabilities in version 5, and then you can have privilege escalation even on this version. So this is the first method of getting root. Okay. Any questions so far? Does anyone have any question on this method? Okay, no questions. Let's move on to the second method. So you are working in a Linux system, you got a normal access, and there is no public exploit, there is no vulnerability on that version. Okay, so you try to do uname -r, you searched exploit db, you could not find any exploit. There are no major critical vulnerability on that version. What do you do next? You try to see and search for services running as root, and then try to investigate those services and see if you can find one that is exploited. Okay, so first we need to check the current processes that are running and check processes that are running as root. So on Kali over here, if I type something like ps with flagged AUX, I get a list of all running processes. Okay, the first column is the username that is running the service. And as you can see here, we have got like user root, and also we got user Kali. Okay. Now, since I am a Kali, I am interested on services running as root. So I can filter this by gripping for root. And here I got a list of all services running as root. I need to walk through the list, okay, and try to find what these services are. And maybe, if I'm lucky, I can find a service that should not run as a root, but is exploitable. Okay. A common mistake, for example, is to run Apache server as root. It should never run as root. But if I find on my machine or on my victim Apache running as root, like this one, for example, this is Apache running as root. Okay. It should not run as root. And then if I manage to exploit Apache or find like a vulnerability on the web application on PHP or JSP, then I might be able to get a root access or a root shell. Okay. So do PSAUX and grep for root and investigate all processes. Another example, aside from the Apache server, is MySQL server. Also, it is a very bad idea to run MySQL as root, okay? Because if somebody get an administrative access to the MySQL, even if they are not root on the Linux machine, they are able to become root easily. And this is our next demonstration. Our next demonstration is going to be on a machine we call Raven. Okay, so I'm gonna shut down Typhoon for now. I no longer need Typhoon. I need Raven. So run Raven, another beautiful machine you can download from Vulnhub and practice hacking skills on. Okay, Raven is running. Where is Raven? Okay, here is Raven. Okay, so I have Raven now running. Let me close this one. Let me search for its IP address nmap -sn 192.168.127.0/24. So I said 1, 2 are reserved, 254 reserved. Most probably 250 is the Raven, since 139 is reserved is my Kali's IP address. So I already have access, SSH access to Raven. So SSH with the username Raven at 192.168.127.250 with the password that I have set before to Raven. Okay. As you can see here, the $sign. Okay. And if I want to get the full prompt, the PTY prompt, I can execute this Python line, import PTY, pty.spawn, spawn for me bin bash, and then I managed to get this whole line. So Raven, username Raven, at host Raven, and then the current directory, which is the root directory, okay, and then the prompt $sign, which means I am not a root, I am a normal user. I don't know if uname -r can work here, 3.16. Maybe you can find a vulnerability for this version. Okay, I haven't tested it on Raven. Okay, Raven is more known for another type of privilege escalation, which is through the services running as root, particularly MySQL running as root. Now, during our, like, if you work on this machine enough, you will notice a few things. You will notice it has a web server. So if I access here HTTP and then the IP address of Raven, okay, it has a web server and it is running WordPress. And we all know that WordPress uses MySQL, and we all know that WordPress includes the root password for MySQL on one of its folders, okay, on the web server itself. So if I go here on Raven and I try to do psaux grep root, and these are all the services running as root. Particularly, I have this one, I have DHCP client, RPC bind, RPC systemd login, okay, SSHD, the daemon, and I have Apache also running as root, and I have MySQL running as root, okay, and this is very dangerous. This is very dangerous. Since I know this web server has WordPress, Okay, I can check the configuration files of WordPress. The configuration file are generally are under var www html WordPress. Okay, these are WordPress configuration files, and there is a file called wp-config. This one. This includes the configuration of WordPress and most often include the root password for my SQL database. So if I manage to dump this file, okay, I can see the MySQL root password. This is not the root password of Linux. Okay, don't get confused. This is not the root password of Linux. This is the root password of MySQL database. So I can access the MySQL database and control it. And this is the password. Okay, if I want to know the exact version of my SQL, okay, I have the command dpackage -l, and then I grep for my SQL. And as you can see here, my SQL server has the version of 5.5.60. Okay, now this particular version, if I have access to it as administrator, a database administrator, okay, I can use it to write and modify files that only root can modify. Okay, and one way to exploit this is to create a function inside MySQL, a function, something we call user defined function, UDF. Okay, UDF, I'm gonna write it on the chat here, UDF. Okay, user defined function, and then I would instruct this function to execute commands for me as a root. Okay, this is the entire idea for it. And if you would like to do a search for UDF running as root, you can go again to, you can simply search for it on Google. So MySQL UDF exploit, or let me see, UDF privilege escalation. And it is right here. So if your MySQL is version 4.x and 5, okay, then you are able to control MySQL and make it run commands as root. Okay, and there is a C code for it. And here there are the exact instructions of how to compile this file. Okay, and once you compile it, what do you need to do on MySQL? Okay, and we will explain exactly what this does. Okay, to create the function that allows you to control the Linux and spawn a root shell. If I go down here in this C code, I will see a function called doSystem. Okay, doSystem is the function that I want to have inserted in my SQL, and with doSystem I can execute commands as shell through my SQL. So as if I am running commands on my terminal, just like here I have ls, for example, or pwd. Using the doSystem, I can execute shell commands through my SQL. The only difference is when I execute it here on the shell, I am executing those commands as a normal user. But when I execute them through my SQL using the doSystem, I am executing them as root. Why? Because my SQL itself is running as root. Okay. So here in the slides, we found MySQL running as root. Okay, this is the UDF user defined function. Okay, so with user defined function, this is a feature in MySQL called user defined function. Anyone who has studied MySQL or is a database administrator knows exactly what UDF is. You can customize your MySQL and add additional functions. Okay, and we have an exploit 1518 which allows you to insert a UDF called do system to execute your own command. Basically, any function that you would like to implement as a UDF, it needs to have a file .so shared object stored under user lib mysql plugin. Okay, so when we compile the exploit, we need to insert it here. However, since we are a normal user, we cannot dump our SO in the plugin directory. Only root can access this directory. However, because we have access to MySQL can do the trick for us, can insert the plugin, and then we can use it. Okay, and this is how we do it. So since I have a normal user now, I know the username and password of the of my SQL database. Okay, now all I need to do is to control the database and compile the code. So let me access exploit DB and type for 1518, which is the exploit. Sorry, not here. It's 1518. No, this is the one. So this is the one I'm interested in. As I said, we go to the row. Okay, we need to download it. All the instructions, by the way, are here. Okay, how to compile it and move it. So I copy this line, and then on my Kali machine, I'm gonna compile it on Kali, not on Raven. Okay, so I am here, wget this file. I got this file, and then I need to move it and make it UDF. Let me call it UDF exploit dot C. So this is .c UDF. This is the one. Okay. So cat UDF exploit. This is the one we have just downloaded. All I need now is to compile it. So GCC. I'm gonna compile it not as a binary file, but as a shared object, because it has to be .so for it to be a plugin inside my SQL. Okay, and then -o, I'm gonna call it UDF exploit, and then UDF exploit.c to link it, and then I should have the shared file over here. Sorry, we did a mistake. We compile it as a binary, as ELF, but we said we need to have it as a shared object, so the output need to be .so. So this is the file we are interested in, .so. I'm gonna publish this through Kali, through the web server of Kali. So sudo copy udf exploit.so to my web server directory. Once it is copied, all I need to do is to run Apache server. Now Apache to start. I have it ready. So on Raven now, I can go to a temp directory. I need to download the shared object file from Kali to my local machine, to my Raven machine. So wget, another wget 192.168.127.139. This is the IP address of Kali. We called it UDF exploit.shared object. We downloaded it. It's right here. Okay. Since I have it here, if I attempt to copy it directly in the MySQL plugin directory, I'm gonna get an error because I don't have privilege. But what I can do is I'm gonna access the database itself, okay, with the root password that I have got from the configuration file of WordPress. as you remember, event security. Now I am at show databases. What do we have? The MySQL database is the main database of MySQL in which you can define content, okay, in which you can define functions, and you can do a lot of dirty stuff in it. So use MySQL. Now I need to copy this file. Remember, my my entire objective now is to copy this file as a plugin and then use it. Okay, so I'm gonna dump this file, import this file as a binary inside the database, and then export it as a file to the plugin directory. And the trick goes like this. I'm gonna create a table, and we will name this table UDF Exploit, okay, that contains a binary long object or blob, binary long object, and the binary long object, the blob, is gonna hold the shared object temporarily. So I created this table, and then I'm gonna import the shared object file, the library inside the table. So insert into UDF exploit, okay, insert into UDF exploit values, the following values. The values needs to be the file that I have downloaded, or the shared object files, okay, and the file is stored in temp UDF exploit.so close semicolon. So now the file that I have downloaded has been imported inside a table, okay, inside my SQL. Now I need to export it from the table to the plugin directory that only root can write. So now I'm gonna export it using select. So the import was using insert, the export will be using select, all from UDF exploit. So I am selecting the file from UDF exploit, okay, and then put it into dump file. So dump it into the following file: user lib mysql plugin, and then call it UDF exploit.so. Okay, it's typing over the same line. Okay, probably there is a mistake over here. Select all from UDF exploit, and then into dump file, put the path user lib mysql plugin UDF exploit.so single quote semicolon. Okay, so I managed now to extract the file and dump it into user lib mysql plugin and call it UDF exploit. This is the whole trick. I managed now to transfer the file into a directory that only root can write. Okay, so because MySQL is running as root and I have access to MySQL, I was able to dump it into the plugin directory. Once it is in the plugin directory, I can create the function do system, as we have seen on the source code, do system, and it has to return an integer with shared object name UDF exploit.shared object. Okay, the function already exists. Drop function do system. It existed from previous attempts, from previous trials. So rerun the command to create the function. UDF exploit. Okay. Now I have the function do system ready. All I need to do, all I need to do is to run netcat and establish a reverse shell to my Kali Linux, and the reverse shell is gonna be root shell. Okay, root shell, since do system will run as root. However, in order to establish my reverse shell, I'm sure you all know that we have to run a listener using netcat -L -V -P. I'm gonna write it, I'm gonna make it on port 2587. And in here, let me use the do system function to execute netcat connect to Kali 127.139 on port 2587 and execute bin bash close semicolon. So here I got the connection from Raven machine, and very easily I can simply do the trick, the Python line to import PTY and have PTY access or PTY shell bin bash. As you can see here now, I am root at Raven and this directory. So if I go to root, I am at the home directory of root. Okay, I can even check the flag, cat flag 4.text. Okay, and I have the flag. So I have a session now with the root permission, and on here, my SQL, I have limited permission. So if I close this one and I exit this one, I get back here. Okay, it's still okay. This is my SQL, and if I quit my SQL, I am back to Raven. Okay, and I have limited mode or limited privileges. Okay. Any question on this? Any question on the UDF user defined function, MySQL, and what was being done here? We have really exploited MySQL that is running as root, okay, in order to establish and elevate our privileges and have a root shell. Is it clear so far? Any question before moving on to the next phase or to the next technique? Okay. The second now, or the third technique, okay, this is basically what we have explained, is to exploit something we call set user ID programs. Okay, and this is very tricky. Okay, not so many people really understand what set user ID except really Linux administrators. Set user ID is a file permission. I'm sure all of you who have worked with Linux know what file permissions are and how they are structured. You know, on Linux, if you type, for example, like on Kali, if you type ls-al, you can see each file has permission over here. The read, write, execute for root, read, write, execute for group, and read, write, execute for others. Okay, which bit is set, which bit is not set, and then you can convert this to binary like 777 or 000. Okay, there is something we call set user ID. Generally, when you run a program in Linux, okay, when you run a program in Linux, the program becomes run as the user who runs the program, regardless if he is the owner or not. So if there is a program that is owned by root, but you run it, it is going to run as you, not as root. Set user ID really means run this program as root. This is like in Windows when you right click an app and you say run as administrator. Set user ID provide the same feature. So you run a program as root. Okay. So if I can manage to find some programs that have set user ID bit set, then I need to check if it is exploitable and if there is a way to use it in a non-standard way. Okay, so usually when you type ls-al, if a program has set user ID bit on, you will see an S at the owner instead of X. Remember, in the normal circumstances, you will see RWX, but here we see RWS, and S means set user ID. So there is a way to search for this type of programs by checking the bit that is set, and the bit code for set user ID is 4000. This is the entire map of bit codes for file permissions. Remember, like if you go to the others, you will have 1, 2, and 4, and 7 for the others, and then you have 1, 2, 4, 7 for the group, 1, 2, 7, 1, 2, 4, 7 for the owner. Okay, and so the first 3 bits from the right, 7, 7, 7 for the others, group, and owner, and then the 1000 for sticky bit, 2000 for set group ID, 4000 for set user ID. What is important here is if you want to search for set user ID programs, you need to search for programs that have the bit 4000 set. And the way to search is to use the command find with the flags permission per minus 4000. So this will give me all programs that have set user ID permission. And if I want to be more specific, I need to search for programs that are under user bin. Okay, user bin. So for this, I'm gonna demonstrate this vulnerability on Typhoon. So we go back to Typhoon, but let me switch off Raven first. So switch off Raven. And then fire up Typhoon again. Most probably the IP address did not change, but just for double checking, sudo nmap -sn, just for double checking. Let me check if the IP is still the same or not. It's 248, the same IP. So we SSH to Typhoon using username Typhoon, IP address 192.168.127 dot 248, password 789456123. Okay, I have normal access. I can search now for set user ID programs. Okay, set user ID programs. So find, if I want to search for all set ID programs in all directories, I would simply type something like find root directory per 4000. Remember, 4000 is the bit code for set user ID. Now this might take a really long time, okay, and might give me some unneeded and lots of results, okay, and lots of errors. I can limit my search to user bin, okay, since most programs, most binaries that are important to execution are under user bin. So I have this list now of binaries, okay, that have set user ID on, okay. I need to investigate those programs. I have the head program. Head, you know what head is? Head is a command that outputs the first 10 lines of a file, okay. So, and tail is a program uh, to print the last 10 lines, while cat prints the entire file. So new group, change shell pass, okay, at gpasswd, passwd, sudo, procmail, vim, traceroute. Now, some of these programs have set user ID in a legitimate way. For example, sudo, always sudo has set user ID. So there is nothing wrong with that. The passwd and the group passwd are uh, always have the set user ID bit. However, the Vim, which is a text editor, should not have a user ID set. The same with head. Okay, the same with head. Because I can use these programs now to read and write sensitive files. Okay, to read and write sensitive files. If I would like to cat a sensitive file like the shadow file, we all know what the shadow file is. The shadow file contains the hashes of all user accounts on the system, and only root uh, must read it or should read it. Okay, all others should be prevented from reading it. So when I try to do cat shadow, I get permission denied because I am Typhoon. I am user Typhoon. Okay, I am not allowed to read the content of the shadow file, and this is typical behavior. This is a secure behavior. However, since head has set user ID, it means I can run head program, the head command, as root. And if it runs as root, it can read the shadow file. So if I do head etc shadow, I am able to read the shadow file over here. Okay. Now, of course, I can print more line, control more line using -n, and I have dumped the entire file now. Okay, I have dumped the entire file. Now, what I can do with these, I can take the hashes and crack them offline. Maybe I can get the hash of root cracked. Okay, I can crack, for example, the user Postgres or the user Typhoon, which is my password actually, and I have admin, and I have other users. Okay. Now, what is more interesting is there is also VI. The Vim is a text editor, so I can edit the shadow file and I can insert my own hashes now. I can insert my own hashes. So if I do vim.basic, okay, and then etc shadow, I can edit this file. Okay, let's say I tried to crack the hash of root and I did not manage to crack the hash of root. I can insert my own hash of a password that I already know. Clear? So let's do that. Let me insert now, and let me call this root old. So I'm gonna make it the old root password. I'm gonna insert a new line for root, which is the line from Kali. So here, if I do cat etc shadow on Kali, okay, and the first line is root, I already know the password of this root on my Kali. It is tour, root tour. Since I know it, I can copy the hash and then I can paste it on Typhoon. Okay, I have the hash, and because I pasted it, I am able now to become root using the password that I already know. Since I know the password, and then I can change to root, su root. It's gonna ask for a password. I'm gonna type the password of root that I already know from Kali of this hash, and it is tour. And I managed now to become basically root. So the bottom line is, if I can find programs that run as root, okay, that run as root, which means having the set user ID bit on, I will try to see if I can exploit those programs or one of those programs. And hid is one of them. Hid will give me read access to files that are restricted to root, while the vim will give me write access to files that are restricted only to root. Okay, and the most important file, or one of the most important files on Linux, is the etc shadow file. If I can read it, I can extract the hashes and they crack them offline. And if I can write to it, I can write any hash I want of any user. Okay, so I inserted my own hash of the root account, and then I am able to become root. Any question on this method, exploiting set user ID program? Okay, let's move on now to another technique. Okay, so we have finished now the kernel vulnerabilities. We finished the services running as root with the UDF and MySQL, and we finished the set user ID. Okay, these three are like the most difficult ones. Okay, the rest now will be uh, they will not take much time to explain. Okay, sudo rights. Sudo rights. I am sure that all of you have worked with sudo before. Like if you are Kali, if you are at Kali, and you have a normal user and you would like to execute command like, let's say, ifconfig, it will not work. So you do sudo ifconfig. And the sudo is a feature in Linux, okay, which means set user super user do. Okay, if you have sudo permission, okay, you can become temporarily root and execute certain commands that are allowed for you. Okay, this is the whole idea. So I'm running ifconfig as root using sudo. I can, for example, do, let's say, ping www.google.com. I am running ping as Kali, but if I do sudo ping, I am running ping as root now. Okay, I'm running it as root. The permissions are stored in a file we call etc sudoers. Okay, etc sudoer. This file contains the rules of sudo. So if I want to check this file, sudo vi etc sudoers. Okay, this file, for example, contain the line for root, and it contains this line. Okay, it contains this line, and this line means any user account that is added to the group sudo, okay, will become part of sudo. Now you can see this bit here, all equal all, colon all, space all. This is the whole syntax of sudoers, and I'm gonna explain what these are, the entire all here. The first all before the equal sign means all hosts. So this user, like I have in the line here, Kali, this user account is allowed to use sudo on all IP addresses and on all hosts. So that means if he access through SSH or Telnet or on the local console, etc., etc. Next, after the equal sign between the parentheses, we have all colon all. The first all means all users. The second is all groups, which means if I sudo, okay, if I sudo a command, I can run this command as any user I want or any group I want. The last all is the most important all. This is what defines the command. If it is all, it means I can use sudo with all commands on Linux. Instead of all, an administrator can specify for me specific commands. Like he can say only ls or ping or ipconfig, etc., etc. I can run as sudo. Okay. If it is all, it means run any command using sudo. Now, if I go back to here to my Kali, and I am a Kali user, okay. To check my sudo permissions, I have a command sudo -l. So sudo -l. Sudo -l will tell me what permissions I have. So user Kali, you can read this line. User Kali may run the following commands on Kali. All. All commands you run as all users, run as all groups. Okay. So since I can run all commands, that means I can do sudo and then any command I want, okay, and then it will be executed as root. So when you get a limited access, a normal access to a Linux machine, always check your sudo rights using sudo -l. And if you are allowed to run all commands, you can simply run the command su, which means super user, using sudo. Okay, and in this case, you directly become root. Let me demonstrate this on the following machine. This is going to be also Typhoon. Okay, it's gonna be also Typhoon. So I have Typhoon ready, and maybe I have access to Typhoon. Let me exit. I am back to normal shell now. So I am Typhoon. Okay, so if I do sudo -l, okay, when you run sudo -l, you have to know the password of your account. So if you manage to access an account illegitimately and you do not know its password, you cannot check sudo and you cannot use sudo. But in this case, we know our password of Typhoon, okay? And it says user Typhoon may run the following commands on Typhoon, all. That means I can easily become a root using sudo su, and here you go, I am now root. Okay, so sometimes you access a machine as a normal user, you compromise, let's say you crack a hash, and then you SSH using the password that you have cracked, and you are normal user. Directly check sudo permissions, okay, and see what permission that cracked user has. If all, game over. You can become root in matter of a second. So that was the fourth type now, the sudo rights. Any question regarding the sudo command and the sudo rights? Is it clear so far before moving on? We only have two techniques, okay? And they should not take more than 10 minutes or 15 maximum, okay? Uh, if you have any question, just let me know, guys, on the chat. Okay. This is sudo. Okay. The fourth technique is something we call cron jobs, badly configured cron jobs. Okay, badly configured cron jobs. First, let me tell you something about cron jobs. In Linux, in Linux, just like in Windows, you can have scheduled tasks. You can have a job or process or a service that runs at a specific time uh, or periodically in a recurring fashion. Just like exactly in Windows, you can have a scheduled task and then it runs each day at 4 p.m. or it runs every minute or every hour, blah, 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 blah. The equivalent of a scheduled task on Linux is called cron jobs. Cron jobs. And to check any cron jobs for your own user account, you type cron tab -l. Okay, and if I was root sudo su, I can check cron tab -l. Sorry, cron tab -l. No cron tab for root, no cron tab for Kali. There is no scheduled task. This is what it means. However, sometimes if I exploit a machine, okay, I might see some cron jobs running periodically in a way that is not properly configured. What I mean by that is the following. The process, the script that runs every minute, okay, it may run as a root, but other users can write to it and change the script. So I have a script that I can write to, but it runs as root using the cron job. Because of this feature, if I can add to that script a command, okay, or a line of code, that line of code is going to be executed as root, okay, not as my account. And then using that command, I can establish a reverse shell using netcat and have it spawn a root shell for me. Let us do this example using using the following VM, which is Mercy. The machine we are going to use now is called Mercy. This is another machine you can download from uh, Vulnhub. Okay, it's called Mercy. I'm gonna run it. It has a misconfigured cron tab job. Okay, it has a misconfigured cron tab job. Okay, so I'm gonna check the IP address first. Which IP address using nmap 168.127.0/24. Most probably is 252. This is the IP address. Okay. This machine does not have a direct SSH to it. Okay, it needs something called port knocking. However, it's vulnerable to a Tomcat default username and password and Tomcat upload vulnerability. So I'm gonna exploit it first and get a normal shell using Tomcat upload exploit, and then I'm gonna explain the cron job exploitation. And for Tomcat, to exploit Tomcat, I'm gonna use MSF console. This has nothing to do with the privilege escalation. This is typical normal, typical remote server-side exploitation. okay? But after exploitation, I'm gonna get a normal shell, and from there, I'm gonna elevate my privilege. So the exploit I'm gonna use is multi HTTP Tomcat manager upload. Okay, set the R host to 192.168.127. I believe it's 252, and then I need to set the port to 8080, and then I'm gonna set the HTTP username. Okay, the HTTP username has been extracted before, okay, and I already got it. So we're simply gonna access, this is what is already built in the system. HTTP password is going to be um, based, okay, and then I'm gonna run the exploit. Okay, I got the shell, and then from here I do my little Python line to import the pty spawn to get a pty shell. Okay, now as you can see here, I have username Tomcat at Mercy, and then I have the prompt $, which means I'm a normal user now. Now, once you exploit a system, okay, and you have tried sudo, there is no sudo. So sudo over here, okay, I need the password for Tomcat, which I really don't know, okay. Okay, so I cannot use sudo. Set user ID did not work. Vulnerabilities at the kernel level, it's 4.4. Maybe there is no vulnerability for this level. One thing I can attempt to do is to check the cron jobs, okay, is to check files that may run regularly. And this, if you do enough intelligence gathering on this machine, you will find that there is a file that runs every 3 minutes, okay, that runs periodically, and it types a timestamp for the web server. And this file is available under username and under the home directory of username we call Fluffy. Okay, so I will try to become Fluffy. Okay, now you don't have to worry about getting the password of these accounts. These are already in a clear text and some other phases during the exploitation. But my concern here is really to get to the cron job tab, to the cron tab jobs, spawn bin bash. Okay, who am I'm Fluffy. So if I do enough investigation, I will find there is a file under home fluffy.private secrets. This file time clock, okay, if I check its permission, I can see that it is owned by root, okay, and yet anyone can write to it and execute it. Now, this file, if I do cat over here, time clock, it's a shell script. It's a bash shell script, and its major function is to print the current timestamp to the time file. And since time changes, it has to be periodic. It has to run every few minutes and then print a new time. Now, this is the first catch. It is running as root, it is executed, and the good news is I can write to it. If I can insert my own line of code, my own bash code, that bash code is going to run as root. So if I establish a reverse shell using netcat, using this script, I am able to have a shell as root, not as a normal user, the one I have it now. Luckily for me, I can extract a netcat. I can extract the payload from Amazon Venom from Metasploit, okay, using cmd unix netcat reverse, okay, lhost. So I can extract the payload, okay, which is actually a shell script that would establish a reverse shell for me using netcat. This is built in into Metasploit. Lport equal, let me use 3214. We oftentimes we use Amazon Venom to generate standalone backdoors using the most common payload, which is Meterpreter. But in here we are not using Meterpreter, so probably it's sorry, it's maybe reverse netcat. 1 second, it's reverse netcat. Reverse netcat. CMD. Let me check. Okay, I got it. So it's reverse netcat. This line, if I can execute this line as a shell, it is going to attempt to establish a reverse shell for me using netcat. But for it to succeed, of course, I need to have a listener -L -V -P on that port 3214 3214. So I have my listener ready. All I need to do is copy this line. I need to insert it on the cron job on this file. So echo to time clock cat time. The last line over here is the one that I have just inserted. Remember UMYF and in here UMYF. By the way, there are two lines you can see here, make FIFO. Okay, these are from previous labs we have done. So if you download Mercy, you will not find these lines by default. So initially the script only covers this part. Okay, and then we have added these two before, and now we are adding a new one. Since it is added, all I need to do is to wait for this job to run at the next time. So once it is run, I should have my root shell, my reverse shell established with netcat over here. Okay, you can see that I got a connection from Mercy. I can do my Python line import pty.spawn bin bash, sorry, and now as you can see I am root. I have elevated my privilege. So always check for files that are running regularly. Okay, and since I am root, by the way, I can type something like cron tab to verify -L, and I can see here time clock runs every 3 minutes. This is 3 minutes. Okay, so time clock runs every 3 minutes. It runs as root, yet normal users can write to it. This is the whole trick. Okay, this is the whole trick. This was the fifth technique to elevate your privilege. Any question on that, guys? The last one is really, really very simple. Okay, I'm not gonna do like a demonstration on, but it is something that might give you sensitive information. The last technique is how to extract sensitive information from bash history. So when I access a shell, a normal user, okay, let's say I am here, Fluffy, okay, who am I? I'm Fluffy. If I go to the home directory of Fluffy, okay, there is a hidden file called .bash history. The bash history file contains the history of the commands executed by the user, in this case Fluffy. And if I check the history, I might be able to see some sensitive information that he have executed in the past. Some of these sensitive information can be passwords that he has typed, can be directories, can be IP addresses, which might help me to do privilege escalation. So cat.bash history, and I can see some of the commands, by the way, I have executed them myself right now. Okay, so oftentimes you might find like SSH command with the password written on the line itself. So if he accesses SSH to a certain account, okay, using username XYZ, okay, with the password, uh, like at the IP address of host name, for example, and then -p, and then he would give the password. The password would be written in the bash history, and then I might use it, and this might be the root password. Okay, um, this is the last technique. So let me review now all the techniques. I'm gonna go back here. So the first technique is to check the kernel version, okay, and see if there are any vulnerabilities associated with that kernel version. And then you might be lucky to find an exploit for that kernel version. If yes, that's good. If no, try to check for services running as root using the command psaux and the grep for root. And we have demonstrated MySQL running as root, and we have uh, username and password to the MySQL, and we managed to create the UDF, user-defined function. And with user-defined function, we managed to have a function that executes command for us through MySQL as root. Once you have exhausted this technique, check the sudo write with sudo -l, okay? And if you can execute commands with sudo, then simply sudo su and become root. Next, check the set user ID programs, okay? Programs that have the bits 4000. And once you have 4000, once you have these, the list of these commands, try to see how you would exploit one of these. And we have seen how we can exploit head and vim commands to read and write sensitive files like shadow file. The fifth technique is badly configured cron jobs, and this is we have seen how like a script that runs regularly and it runs as root, yet everybody can write to it. We can make it execute our own commands as root, and we can make it establish a reverse shell uh, using netcat, and it's gonna be root shell, not a limited user shell. And finally, We can check the bash history, okay, in the hidden file dot bash underscore history. We might find there some sensitive information, some passwords, some directories that are important to us. That's all for this webinar, guys. Thank you very much for joining and listening. If you have any question, let me know. Just type them in the chat. I'll be more than happy to answer you. Okay, thank you guys. Thank you, Ali. Thank you, Joseph. Thanks, Roy. Eli is asking, all hashes can be decrypted. Uh, it depends on the strength of the hash or the strength of the password. So if the password is very, very, very strong, it can take long time. Okay. If the password is weak, like short in length or easily guessable or in the dictionary, you can crack it quickly. You can decrypt it quickly. And by the way, even a strong passwords, hashed passwords, maybe now is very difficult, but a year from now or 2 years from now, with supercomputers advancing, the time to crack them becomes shorter and shorter. So what used to take like a year in the past, now it can take like hours. Okay, and what might take years now maybe can take hours next year. Who knows? So the length of cracking a hash is always relative to the strength of the password. So it's not guaranteed every time you get a hash you can crack it, but most users, we all know most users use uh, passwords in dictionaries, and they don't use really strong and long passwords. So in this case, you can crack most of them. Okay. Any other question? Thank you, Haitham. All right, guys. I appreciate your attendance today, and I look forward to seeing you in future webinars next month. Bye bye.